Hi there. So today we're going to be discussing mechanics, which is one of the underlying foundational principles that basically all of physics is based off of. So mechanics is really just the branch of science that deals with motion. So it's split into two main things. So kinematics and dynamics are the two main fields of study within it, where kinematics is mainly the study of where an object will be, and dynamics is the study of why an object will be there, right? So motion and really position. So kinematics was something that was studied and really pioneered by Galileo. So many of his formulas will come up. And in dynamics, that was mainly Isaac Newton's field of expertise. So those two characters will come up a lot when discussing each of those. And in both of these, there are three main ideas, principles that you're going to need to understand. So the first one is displacement. So displacement in general terms is how far an object has traveled, but it gets a bit more complicated than that. So I have a little diagram here to show the difference between total distance traveled and displacement, because there is a difference between them. And it is kind of confusing, especially if you're just beginning. So the total distance traveled by something is the most simple way to explain it. It's the total distance it has traveled. So if you were to have gone through this maze right here, right, the total distance traveled is just the entire black line, right? Now, if you were to take it and stretch it out, it would probably be, pretty long. I actually think it would be too long to fit this way, so I would say it would be around that long, give or take. Now, the total distance traveled here is pretty long, but the displacement only cares about the distance from point A to point B, right? So the displacement, although you've gone more distance than it takes, just to go straight from A to B, the displacement is really just that line from A to B. So oftentimes total distance traveled will be much shorter than the displacement, because the displacement only cares about the shortest possible distance between your starting point and your ending point. You can go as many ways around as you want, but as long as you start and end at A and B, that will always be the displacement. All right. Next we have velocity. And velocity is another topic which does get a bit confusing if you're new, especially the difference between velocity and speed. So velocity is I actually have this paper here. Velocity is the measurement of something's speed, how fast it is traveling, along with the direction it's traveling. So sometimes you'll have that written as directions, as it would be written on a map. So this would be 4 meters per second northeast, because it's traveling northeast. Most of the time in physics, you'll only be dealing with 2 dimensions of travel, or a linear travel, right? So it'll either be positive 8 meters per second or negative 8 meters per second. So the negative is actually the indication of direction in this one. Instead of having a northeast, you just have a negative. Now, where speed differs is that speed is simply the absolute value. You have no other information other than how fast it is traveling. You don't know where it's going. You don't know whether it's coming away or towards you. It's, just the speed. So that's really the difference between velocity and speed. And once you get that down, it's not that bad. And you kind of see it right there. That next is acceleration. So acceleration is really just a change in velocity. So if something is going 8 meters per second and you add force to it, it'll be going 9 meters per second. Most of you will know acceleration in terms of driving a car. So if you're driving 20 miles per hour, you increase the acceleration. You go from 20 miles an hour to 40 miles an hour, or however much it is. So common types of acceleration that you most likely have interacted with, the first would be gravity. Now this one is important. So gravity can either be expressed as negative 9.81 meters per second or negative 10 meters per second. It really just depends on how much accuracy you want, but 10 is most of the time close enough. Now, the reason that gravity has a negative acceleration is because most of the time you'll be discussing objects that are traveling in the opposite direction of it, such as projectile motion is always going to be projected upwards against the force of gravity. Now, acceleration doesn't always have to be something speeding up, whereas you can see in the case of gravity, gravity actually speeds things down, slows them down. So you'll notice this when you throw something up in the air. You'll notice that as it reaches the top, it'll slow down. Its velocity becomes slowed. Now, this isn't it being just slowed by wind resistance or air. This is actually an example of deceleration or a negative acceleration. So a negative acceleration, all it's really doing is just pushing in the opposite direction as the velocity and slowing it down. And eventually it comes to zero. And then immediately after, the object is at rest at the top of the curve of its motion, it'll start to come back down. As it comes back down, gravity will actually begin to increase its speed and then accelerate it. So the whole point of this, and I can actually give you a little drawing. So say that you have an object going from here, and its direction is up there, and it's going to fall back down here. So right at that top point there, its velocity will be zero, speaking in only up or down terms, in the y direction. The most important part here that gravity has an effect on is that gravity will be decelerating or slowing down the velocity on this end, and it will be increasing the velocity on this half of it. However, it's both the same thing. They're both just arrows pointing down. It's both negative 9.81 meters per second. So acceleration, can equally affect things. Doesn't have to change or anything. The next type of acceleration is, instead of linear, is going to be radial or centrifugal acceleration. Now, here's a little example that can show that acceleration doesn't necessarily have to be a change in the speed, right? Because here you had, say that you shot off a rocket at 20 meters per second. The 20 meters per second changes throughout this entire curve. It's not going that fast the entire time. Relative to just going up or down, because that's the only way that it's being accelerated or decelerated. But there could be a way where you can have the exact same speed the entire time, but still have acceleration, right? So imagine something is traveling in the direction of a circle. So, at this point, it'll have 8 kilometers per second in that direction. We could just say that's going southeast. And then this one will also be going 8 kilometers per second, and we could just say it's going south because it's going directly down. And then this one will still be going 8 kilometers per second. Let's just say southwest. So, these are just, if something was really in orbit, we would not be using these, but just for simplicity's sake, for ease of understanding, I'm going to simplify much of this into just the same number, right? But you'll notice either way, it's still going to be 8 kilometers per second the entire time. So what's actually happening here is that the velocity is still changing because these directions are changing, right? But the speed itself is not changing. So there are instances where velocity can change, but speed will stay the same. So you're not going to have to get into that now, But later on, it is a very important thing to know because the differentiation between velocity and speed and how acceleration factors into both of them will really help you out in your understanding. All right.